Welcome, GeoTrig. This is section 3-4, parallel lines and triangles. The essential question is, what is the sum of the angle measures of a triangle? Is it ever different? Let's begin. So, parallel postulate. This is the postulate right here. So, through a point, not on a line, there's only one, and only one line parallel to the given line. So, does that mean I got a line Q and I got a point P? So, it means that if I draw a line, there's only one line that's parallel that goes through P that is also parallel to Q. And that kind of makes sense, because if I draw this line P right here, there's only one way to make this parallel, because if I kind of twist the line like this or like this, it's going to cross Q. Even if I just a little bit, eventually off screen it's going to cross. So there's only one way to make this parallel. There's infinite points through point P, or infinite lines through point P, but there's only one line that is actually going to be parallel to line Q. We're going to use that for the triangles. So another theorem is the triangle angle sum theorem. And this is something you probably learned in 6th grade, but here it is again. The sum of the measures of the angles of a triangle is 180. So measure A, B plus C has to equal 180. Well, that's something you were learned about in 6th grade. I don't know if you proved it. But we're actually going to prove it right now. And we're going to have to use that parallel postulate. So here's the proof. The proof of that triangle angle sum theorem. Given a triangle ABC, prove that the measure of angle A plus measure of B plus measure of C equals 180. So the first thing we're going to do to prove this, and I'm going to make my two row proof, so statements and reasons. First thing I'm going to do is draw the line PR through B that is parallel to segment AC. So you pick some side of the triangle, and you're going to call that a segment, and then the other side you're going to draw another line parallel to that. So it's already drawn up here, and this is a line PR, and it's parallel to AC. So the reasons I can do that is that parallel postulate. Well, what's the next step? The next step here is we know that the angle PBC and angle 3 are supplementary. So angle PBC and angle 3 are supplementary. Why do we know that? Because angles that form a linear pair are supplementary. So I'm going to say linear pair. And because we've done that before, that's chapter 1 stuff. Okay, the next thing I could say is that the measurement of angle PBC equals plus the measure of angle 3 equals 180. So we're going to say the measure of PBC plus measure of angle 3 equals 180. And that's just the definition of supplementary angles. So I'm going to say supplementary angles. Angles. Okay, my next step. Step 4. Well, if I know that, I'm going to break down the measurement of angle PBC. So PBC is angle 1 plus angle 2. So the measurement of angle PBC equals measure of angle 1 plus measure of angle 2. And we know this because angle addition postulate. This was chapter 1 again. So angle addition postulate. An angle is the measure of the big angle is the measure of the two angles inside of it. Okay? Next step. Well, if I know all that, I can say the measure of angle 1 plus 2 plus 3 has to equal 180. So measure of angle 1 plus measure of angle 2 plus measure of angle 3 has to equal 180. How do I know this? It's substitution. So I'm taking this measure of angle 1, 2, substituting it for PBC. So this is substitution. Okay, my next step. Well, I know those all add up to 180. A few things I can see from the measurements on the triangle are angle 1 is congruent to angle A, and angle 3 is congruent to angle C. So 1 is congruent to A, and 3 is congruent to C. Why can I say that? Well, it's the stuff we learned 1 or 2 sections ago, where we said that if lines are parallel, then alternate interior angles are congruent. So that's going to be part 6. I'm going to say parallel lines, alternate interior angles are congruent. Alternate interior angles congruent. So that's, I think, was about 2 sections ago. So the next step, I know those are congruent. I can say the measure of angle 1 equals the measure of angle A. The measure of angle 3 equals the measure of angle C. I can say that because congruent angles have equal measure. So, oops, not that one. So congruent angles have equal measure. Alright, my next step for that, and this will be the last step, step 8. Well, I can say that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And this is because of substitution here. So I can substitute measure of angle A for 1 and measure, ooh, this said 3 here. This was supposed to say C. So measure angle 3 equals C. And then we could say measure of angle B equals 2 because they're the same angle right here. And this is all through substitution. So that's how we get this. Proof of the triangle angle sum theorem. Another thing we can do this chapter, exterior angle of a polygon. So it's an angle formed by a side and the extension of adjacent side. So here's 3 examples of this, and angle 1 in all 3 cases is the exterior angle. So the side for this one is, this is a side of a polygon, and this is that extension of another side. Same over here. You have a side of a polygon and we have an extension. Have a side of a polygon and extension. So the one neat thing about these exterior angles is we have the triangle or triangle exterior angle theorem. What does that say? The measure of each exterior angle of a triangle equals the sum of the measures of the 2 remote interior angles. So basically the exterior angle equals the other 2. The measure of angle 1 equals measure of angle 2 and 3. So we can use this. Let's try some examples. Pause the video. Alright, let's begin. We know that triangles have to add up to 180 degrees, so this is just figuring out values of x and y using that property. So this triangle right here, ABD, I can say that 43 plus 59 plus x has to equal 180. And it's a matter of solving for x. Combine 43 and 59, I get 102 plus x equals 180. And I subtract 102 on both sides, so I get x equals 78. That's x. Let's solve for y. So now this other triangle, BDC, I can say that 49 plus y plus z equals, so that has to equal 180. Well, I don't know what y and z are, but I also got a big triangle right here, right? So before I figure out this equation, let's do the big triangle ABC. Now I can say that angle A, which is 59, plus angle B, which is 43 plus 59, or we can call that 5292, plus z has to equal 180. So let's solve for z right here. 59 plus 92 is going to be 101, 151 plus z equals 180. And then you subtract 151, z is going to have to equal 29. So there's z. But now we can use that to solve for y. So I'm going to erase this over here. Alright, so I got this triangle BDC is going to be 49 plus y plus z equals 180. And I know z equals 29, so it's going to be 49 plus y plus 29 equals 180. Combine like terms, that's going to combine to 78 plus y equals 180. Subtract 78 and y is going to equal 102. So my x is 78, y is 102. And that makes sense because, and you know what, I didn't even need to do all that work. I knew angle x and angle y were supplementary angles here. So when I found x, I could have just subtracted that from 180 and determined y was 102. So there's more than one way you could have solved this problem. But I kind of did it the long way. If you look at the problem really close, you could have just figured out x and then said, oh, y's got to be this. So, good. Try these examples. Pause the video. Alright, measure of angle 1. So the exterior angle postulate said 1 has to equal these 2 angles added up. So measure of angle 1 equals 80 plus 18, so it's got to equal 98. Measure of angle 2. Okay, so this is a little trickier. So 124 has to equal 59 plus measure of angle 2. So we'll just subtract 59 on both sides. And if you subtract 59 on this side, it's going to get 5. So 65 equals measure of angle 2. So your answer is 65. All right, I got one more. Okay, look at this picture. What is x? Pause the video. All right, let's solve for x. So I got, this is angle 30, this is x, and this exterior angle is going to be 80 degrees. So to solve for x, let's see what I can do. Well, if this is 80, I know this right in here, there's two ways to do this. This right in here has to be 100. So then I can just do the triangle. They have to add 180. So we got 30 plus 100 plus x equals 180. So 130 plus x equals 180. And that means x has to equal 50. Another way I could get through that is that exterior angle, the triangle exterior angle theorem. So I could have said, okay, 80 has to equal 30 plus x. And doing the same thing, subtracting 30, you would get x equals 50. So either way would get you the right answer. That's it.